Today, Monday morning, already 10 o'clock. So late. Okay, let me try the Uber. Okay, office, ETA, 250 rupees, location confirmed. Okay, great. Okay, it is coming. Let me see. Oh, already come. Great. So fast. OTP 2356. Okay. Thank you. Namaste, sir. Myself and my co-driver could be able to come on time, right? Let us go. Welcome each one of you to our YouTube channel Truly AI, the channel which makes artificial intelligence simple, relatable, real and easy to understand. I am Dr. C.B. Abraham. Today we discuss about the AI behind Uber trip. Let us go for the drive. First thing first, as soon as we tap the Uber app, the system tries to identify the nearest driver for you. How Uber does this? For this, we take a small demonstration. Suppose there are 6 riders or passengers requesting for the Uber car, and there are 6 cars or drivers available to pick up. Green, the riders, passengers. Red, the drivers. In usual convention, we assume that the nearest one, this passenger can be allocated this car, this passenger can be allocated this car, this passenger, etc. Using that convention, this passenger who is at the extreme end has to wait a long time in order to get the car allocated. This is a small, simple scenario. Instead of that, assume that a big city with thousands of passengers requesting for the ride and thousands of cars waiting to be allocated, and this type of arrangement may not work. For that, Uber uses a sophisticated network graph algorithm for the optimum allocation. Each of the riders and each of the cars are considered as nodes in a huge network graph. Using sophisticated graph algorithms, the Uber could be able to allocate optimum time, and each of the passenger could be able to get the driver as early as possible. This is what Uber does for the optimum allocation. Next, that familiar line, your driver comes in 2 minutes. How does Uber manages that? Uber uses a sophisticated algorithm called DeepETA, Deep Expected Time of Arrival, based on billions of previous trip data. Uber uses historical data, its own trip data, sensor details, the climatic changes, the local festivals and live traffic data, etc. Based on that, a sophisticated algorithm works, and it could be able to give a live update about how much is the time of arrival. It uses its own strategy, and correspondingly it could be able to change the time according to the real-time ground situations. For example, my sabji market is hardly 2 kilometers away. Usually it takes only 5 minutes, but in Saturday evening it might take almost 10 minutes depending upon the road traffic and other conditions. And that is what Uber makes it special and exclusively for us and at the real time. My office is around 20 kilometers. Usually my Uber trip takes around 300 to 350 rupees per day. But suppose it is a Monday morning and peak time around 9:30 to 10, and this Uber trip can cost me around 700, 750, sometimes even 900 rupees. How it is done? Uber uses a mechanism called surge pricing. Let us see how the surge pricing mechanism works through this simple demonstration. In this case, assume that we have around 20 riders, all the green riders, passengers waiting for the car, and only 6 cars are available, 20 demand and 6 supply. Economics comes into play and automatically the prices go up. Uber's AI automatically increases the price. As the ride price increases, other nearby drivers will be notified. They automatically come into that location and automatically the prices could be able to come down. Therefore, in this way, gradually after some time, prices stabilizes. And in this surge pricing, AI and the economics comes hand in hand. Uber uses sophisticated time series forecasting in order to predict the spikes at what time, at what locations. And the sophisticated reinforcement algorithm could be able to dynamically reduce the prices so that the customers could be able to afford the ride. Therefore, when you come across surge pricing next time, maybe it is advisable to wait for some more time so that the prices will be able to come down. Once the ride starts, Uber's AI continues working. It looks for optimization of the route at the real time on a continuous basis. It works slightly different from the standard GPS. Consider the Google map. Suppose we want to move from Mumbai International Airport to Navi Mumbai International Airport. The map shows the timing to be 1 hour 4 minutes. The Uber route optimization works slightly different. It instantaneously changes, and that is the reason why many times you could be able to see that your Uber drive takes a big turn and taking some unfamiliar routes, because it anticipates the next 10-15 minutes what can be the traffic, and correspondingly it reroutes it. There is some basic difference between the standard GPS like Google Maps or the Uber route optimization. Google Map could be able to be equated like your home kitchen, where you have some menu, some dish to be made, and it could be able to be done as fast as possible. The Uber route optimization could be able to equate as some sort of a restaurant kitchen where many chefs are there, many customers are there, many other things to be taken care, and each services, each facility, each person, their services are optimized. Uber usually takes much more conservative estimate because it wants to give good assurance to the customer that the customer will be able to reach the destination on time. We are back in the familiar place. Do you think that Uber and kitchen have a lot of similarities? Yes, we suppose. Kitchen is the place where lots and lots of activities going on. Washing, cleaning, cutting, cooking, serving, many such activities. Similarly, Uber also takes care of many AI activities. As soon as we book a Uber, it identifies a driver for you. It could be able to calculate the price for you. It gives the estimated time of arrival correctly, and it manages the route optimally in a dynamic way, and at the end it could be able to help you to reach the destination in addition to doing many sophisticated tasks like search, pricing, management, etc. How all these different AI activities done without having any issues? That is provided by a machine learning platform called Michelangelo. Yes, you heard it right. Similar to the 15th century painter who drew iconic paintings, this Michelangelo helps us to provide or orchestrate all different AI activities, and it would help us to reach the destination on time. Therefore, when you take the Uber next time, and when the Uber driver takes a clever turn in between and help you to reach the destination on time, remember, your co-driver help you to reach the destination. The co-driver who was cooked up in the AI kitchen called Michelangelo. Today was a tough day. It is the last trip of the day. Myself and my co-driver could be able to take almost 25 people today. But there is lots of difference between myself and my best friend. I have been trained by years of experience, but he has been trained with lots of data. I see through the eyes, he sees through the experience he has gained over the years. I could be able to take only you, one passenger at a time, but he could be able to take millions of passengers anywhere in the world. Sometimes I get tired, but he never gets tired. Sometimes I am impatient with my passengers when they come very late, but he is always patient, no complaints, and he is my best friend. You can call him, her or it, but mera dost. Thank you for watching. If you enjoyed this ride, please like, share and subscribe. See you in the next video. Until then, truly AI.